Hello friends, welcome back to Relief Tutorials. Today we are going to discuss topic 2 of your chapter 6, angles, parallel line and transversal. Questioner asks, what are parallel lines? See, if two lines, they lies in a same plane and they do not intersect each other, then they are parallel lines. So here we say this two line L and M. So we can say L is parallel to M. Also we can say M is parallel to L. So what are the conditions? Two lines should lie in same plane. They should lie in same plane, first condition, and they are not intersecting. They do not intersect each other. They do not intersect. Then they are called parallel lines. Now what is transversal? So transversal is a straight line. Transversal is a straight line which intersect two or more straight lines in distinct points. Then they are called transversal lines. See, this T is a transversal. So it is a straight line which intersect two or more straight lines in distinct point. Here we see these are the two distinct points where T intersect L and M. We name them as P point and Q point. So as T intersects these two lines at two distinct points, four angles are formed at each point. Say I say this is angle 1, this is angle 2, this is angle 3, this is angle 4. This 5, 6, 7 and 8. So four angles are formed at each point. Now we'll see first we'll discuss corresponding angles. Corresponding angles. Now you see angle 1 and angle 5. These are corresponding angles. Angle 4 and angle 8. Angle 2 and angle 6. Angle 3 and angle 7. In short, see I will discuss this 1 and 5. They are on the same side of the transversal and both lies above the lines. Same thing we can say 2 and 6. And if we call 4 and 8, they are lying on the same side of transversal but below the lines. So there are four pairs of corresponding angles. Which are they? I can say angle 1 and angle 5. Angle 1 and angle 5. Then angle 4 and angle 8. Angle 2 and angle 6. Angle 3 and angle 7. These are corresponding angles. Four pairs of corresponding angles. Then we will say alternate angles. Alternate angles. So alternate angles are of two types. Alternate interior angles. So alternate angles are of two types. First one is alternate interior angles. So which are alternate angles? See this angle 4 and angle 6. These are alternate interior angles. See, I will draw the diagram, just you see here for your understanding. These are the two lines. This is the transversal. So this angle and this angle. See, both these angles, they are lying on either side of a transversal but within the lines. So they are called interior angles, and as they are lying on either side of transversal T, it is called alternate. Whereas in the case of corresponding, see they were lying on the same side of the transversal. Here they are lying on either side of a transversal and within the lines L and M. So this is angle 4 and this is angle 6. So we can say alternate interior angle is angle 4 and angle 6. And this you see we can say this third and this one. So this is 3 and this is 5. If we say 1, 2, 3, 4, 5, 6, 7, 8. So an angle 3 and angle 8. Angle 3 and angle 5. 3 and 5. They are alternate interior angles. Why they are called interior? See, they are lying within the lines. Within L and M, they are lying within the lines. Now we'll discuss alternate exterior angle. Alternate exterior angles. See, I can say, see, these alternate exterior angles are angle 1 and angle 7. Angle 1 and angle 7. See, they are alternate. One is on this side of transversal, one is on other side of transversal, but they are lying above the lines, not within the lines. So, I can say angle 1 and angle 7. Similarly, this angle 2 and angle 8. See, they are alternate. One is on this side of transversal, another is on this side of a transversal, and both are lying one above the line, one below the line. So, I can say angle 2 and angle 8. So, these are alternate angles. Now, we will discuss one more. Interior angles on same side of transversal. On same side of transversal. Interior angle on same side of transversal. See, which are these? I will show you the diagram. This is transversal. Interior angle on the same side of the transversal. 1, 2, 3, 4, 5, 6, 7, 8. Always in clockwise direction you have to start. Okay. So, this angle is acute angle. This angle is obtuse angle C. So, these two are interior angles. They are lying within the line L and M, and they are on the same side of transversal. So, I can say angle 4 and angle 5. These are the interior angle on same side of transversal. Similarly, you can say these two angles, angle 3 and angle 6. So, we have 4 pair of corresponding angles, 2 pair of alternate interior angles, 2 pair of alternate exterior angles, and 2 pair of interior angle on the same side of the transversals. Now, we will see what is the relation among these angles. Okay. Before that, we will learn two axiom. Corresponding angle axiom it is called. Corresponding angle axiom. What are corresponding angle axiom? See, this is the diagram. Two lines L and M. This is transversal T. I told you 1 angle, 2, 3, 4, 5, 6, 7, 8. Now, what corresponding angle axiom is? Axiom 1. If L is parallel to M, this is the condition. L and M should be parallel. If L is parallel to M, then corresponding angles are equal. Then each pair of corresponding angles is equal. If and then, see, this is the conditional statement. This is necessary. A line should be parallel. Then only corresponding angles are equal. So, we can say angle 1 corresponding angle C, angle 1 and angle 5. Angle 1 is equals to angle 5. Similarly, angle 4 is equals to angle 8. Angle 2 is equals to angle 6 and angle 3 is equals to angle 7. So, this is called corresponding angle axiom. Once again, I am repeating, if lines are parallel, then only corresponding angles are equal. Now, axiom 2. It is converse of axiom 1. Converse of axiom 1. What it says? If transversal intersects two lines such that corresponding angles are equal, then lines are parallel. So, it says if corresponding angles are equal, then L is parallel to M. See, once again, if and then, these are called conditional statement. If there is a rain, then road will be wet. So there is a condition. If there is a rain, then only road will be wet. So it is called conditional statement. If is data given, then is to prove. So here it is converse. Here what it says, if lines are parallel, corresponding angles are equal. What is converse of axiom 1? If corresponding angles are equal, then only lines are parallel. If you want to prove that these lines are parallel, then you have to prove that one pair of corresponding angle is equal. Any one pair of corresponding angle is equal. If you are able to prove that, then we can say lines are parallel. Axiom 1, if lines are parallel, then no doubt corresponding angles are equal. So these two axioms are widely used and they are called corresponding angle axiom. Okay, once again what it says, if lines are parallel, corresponding angles are equal. If corresponding angles are equal, then lines are parallel. Clear? See, theorem 1, if L is parallel to M, then alternate angles are interior angles. Alternate interior angles are equal. Clear? See, I will draw the diagram. I will take L and M. This T is transversal. So, no need of proving this theorem. Why? Because it is not given in your textbook, but I am going to prove it. Just look here. You have to remember only statement. If lines are parallel, alternate angles are equal. These are two alternate angles. This is alternate angles. Clear? We will say here 1, 2, 3, 4, 5, 6, 7, 8. First we will write data. What is data? L is parallel to M and T intersect L and M at P and Q respectively. Here we will take this as point P and this will take as point Q. To prove, what you have to prove? You have to prove that alternate angles are equal. So angle 4 is equals to angle 6 and angle 3 is equals to angle 5. This we have to prove. Now proof. See, very simple proof. See, now first we will prove 4 is equals to 6. So angle 4 is equals to angle C. Here 4, we have 4. So which is the opposite angle of 4? Vertically opposite angle 2. So I can write here angle 2 is equals to angle 4. Reason? Vertically opposite angles. Clear? How we have done? We have to prove 4 is equals to 6. So we have selected 4. Opposite angle is 2. So 2 is equals to 4. Now 2 is equals to 6. I can say here angle 2 is equals to angle 6. Why? Because 2 is equals to angle 6. Why? We can say corresponding angle axiom. Corresponding angle axiom. See, this is corresponding angle 2 and 6. They are corresponding angles, and we have seen that if you know axiom 1, if lines are parallel, corresponding angles are equal. Here it is given lines are parallel. So if lines are parallel, corresponding angles are equal. That is called corresponding angle axiom. Now see from, so therefore we can say 2 is equals to 4, 2 is equals to 6. So therefore we can say 4 is equals to angle 6. Okay, this is one you can take. You take this as 2. So we can say from 1 and 2. It is proved. Now once again, now you have to prove 3 is equals to 5. See here, 3 is equals to 5. So you will select 3. So 3, the opposite is 1. So I can say angle 3 is equals to angle 1. Reason? Vertically opposite angles. Okay. So 3 is equals to 1. Now 1 is equals to 5. Why? Because we want 5 here. We want 5. So I can say angle 5 is equals to angle 1. Reason? Corresponding angle axiom. this is 3, this is 4. So from 3 and 4, what you can say, 1 is equals to 3 and 1 is also equals to 5. So we can say 3 is equals to 5, the angle 3 is equals to angle 5. Hence, proved. Very simple it is. Have you got it? No need of proving. Just you have to remember that if lines are parallel, alternate angles are equal. Clear? In this way you can prove this. Now, theorem 2. What is that? If alternate interior angles are equal, then L is parallel to M. So converse, theorem 2 is converse of theorem 1. What it says, if alternate interior angles are equal, then lines are parallel. So what you will write here, we say converse of theorem 1. First we will write data. What is given? The transversal T intersect two lines L and M at P and Q respectively. Here this will take as P and this will take as Q. Such that now this I will take as 1, 2, 3, 4, 5, 6, 7, 8. Such that alternate angles are equal. Such that angle 4 is equals to angle 6 and angle 3 is equals to angle 5. So alternate angles are equal and you have to prove. To prove, what you have to prove? L is parallel to M. So now it is given that angle 4 is equals to angle 6. From where we got this? From data. Clear? So it is given that. So now 4 is equals to 6 it is given, but you know that 4 is equals to 2. But angle 4 is equals to angle 2. Why? Vertically opposite angles. Any doubt? See, this 4 is equals to this 2. Why? They are vertically opposite angles. So therefore, this will take as 2. From 1 and 2, what you got? Angle 2 is equals to angle 6. Now 2 and 6 are equal. So we have to corresponding angle axiom. If lines are parallel, corresponding angles are equal. Now 2 and 6, they are equal, but they are corresponding angles. So corresponding angles are equal. So lines are parallel according to axiom 2. Clear? Are you getting? But we can say angle 2 and angle 6 are corresponding angles. And they are equal. So therefore you can say L is parallel to M, axiom 2. Hence proved. Have you got it? It is quite simple. Our theorem is if alternate angles are equal, then lines are parallel. So here it is given that alternate angles are equal. That is 4 is equals to 6 and 3 is equals to 5. It is given. You have to prove that L is parallel to M. So you will select any one pair, this pair, 4 equal to 6. That is data. Now from this you have selected one angle 4. So opposite angle is 2. So we can say 2 is equals to 4. Why? Because vertically opposite angles. From both this we get 2 equal to 6. So this angle 2 and angle 6. Angle 2 and angle 6, they are equal. but they are corresponding angles. They are corresponding angles and they are equal. So according to axiom 2, we can say lines are parallel. Hence, proved. Clear? See now, theorem 3 we are learning. If lines are parallels, if L is parallel to M, then each pair of interior angle on the same side of transversal is supplementary. See, here we have proved that if lines are parallel, corresponding angles are equal. If lines are parallel, alternate angles are equal. Here, if lines are parallel, interior angle on same side of the transversals are not equal. See, these are interior angle on the same side of the transversal. See here. See, this is obtuse angle and this is acute angle. How they can be equal? So here they are not equal. Interior angle on the same side of the transversal is supplementary. You have to prove that 4 plus 5 is equals to 180 and you have to prove that 3 plus 6, this 3 plus 6 is equals to 180. So how we are going to prove this? See, first we have to prove 4 plus 5 is equals to 180. So 4 plus 5 180. So in proof we required 180 and there is angle 4. So we will select this 4 and we will make a pair with 3. Why? Because you know that they are linear pair angles. So their total is 180. So 180 will be included in our proof. So what we can say, here it is P and here it is Q. So you can say PQ, ray PQ stands on line L. So therefore you can say angle 4 plus angle 3 is equals to 180. Reason you say linear pair axiom. Linear pair axiom. Clear? This is one. Okay, but we want 4 plus 5 180. We got 4 plus 3 180. So in place of 3 we required 5. So we have to check whether 3 and 5 both are equal. So check here. See, this is 3, this is 5. They are equal. Why? Because they are alternate angles and lines are parallel. It is given lines are parallel. So if lines are parallel, alternate angles are equal. So we can say here angle 3 is equals to angle 5. Reason, we can say alternate interior angle. 2. Now from 1 and 2. See, 4 plus 3 equal to 180 and 3 is equals to 5. So what you will get? Angle 4 plus angle 5 is equals to 180. Clear? See, angle 4 plus angle 5 is equals to 180. Hence, proved. Have you got? Similarly, we can prove this 3 plus 6 equals to 180. How you can prove? We can say PQ stands on line M. Now, PQ stands on line M. So I can say 5 plus 6, angle 5 plus angle 6 is equals to 180. Reason, I can say linear pair axiom. Any doubt? 5 plus 6 180, but we want 3 plus 6. So in place of 5 we required 3. So in place of 5 we required 3. So I can say angle 5 is equals to angle 3. Reason, alternate interior angle. This is third, this is fourth. So now we can say from 3 and 4. In place of 5 you will write 3. So angle 3 plus angle 6 is equals to 180. Got angle 3 plus angle 6 is equals to 180. Hence proved. So very simple proof. I hope you understood this. Now we are going to prove theorem 4. Last theorem. What it is? If alternate interior angles are supplementary, then L is parallel to M. So data we will see here. So I will draw the diagram first. Same diagram, you know. This is L, this is M, and this is transversal T. 1, 2, 3, 4, 5, 6, 7, 8. This point is P. This point is Q. So if alternate interior angles are supplementary, then lines are parallel. That is converse of theorem 3. What was theorem 3? See here. What was theorem 3? Theorem 3, if lines are parallel, then interior angle on the same side of transversal are supplementary. Here what is theorem over? If interior angles on same side of transversal, if interior angles on same side of transversal are supplementary, then lines are parallel. This is converse of theorem 3. Have you got to what was our theorem 3? Our theorem 3 was if lines are parallel, interior angles on same side of transversal is supplementary. Here we are going to prove that if interior angles on same side of transversal are supplementary, then lines are parallel. Okay. So data, see here. So data we can say, okay, T intersect two lines. We can't write parallel lines, so we don't know whether they are parallels. We have to prove that they are parallels. So T intersects two lines L and M at P and Q respectively such that angle 4 plus angle 5 is equals to 180 and angle 3 plus angle 6 is equals to 180. This interior angle of same side of transversal are supplementary, so their total is 180. So 4 plus 5 equal to 180 and 3 plus 6 equal to 180. Data. Now we are going to prove. So what you have to prove? You have to prove L is parallel to M. So now proof. See how we are going to prove. See, just I will take few points here. Why? Because A, B, C and D. So I can say here this PB stands on T. Okay. So I can say here ray PB stands on line T. So if ray PB stands on line T, then I can say here angle 2 plus angle 3 is equals to 180 degree. Reason linear pair axiom. And also I can say angle 3 plus angle 6 is 180 degree. It is given, no? 2 plus 3 is equals to 180. Why? Because PB stands on line T. So they are linear pair angle and their total is 180. Now I can say 3 plus 6 is also 180. Why? Data. Also 3 plus angle 6 is equals to 180 degree. Reason data. So this I can say 2. Now equating 1 and 2. This is 180, this is also 180. So I can write here angle 2 plus angle 3 is equals to angle 3 plus angle 6. Now this 3 will get cancelled. So what we get, therefore angle 2 is equals to angle 6. Now you see angle 2, this is angle 2 and this is angle 6. Can you see this, or I have to use C here? This is angle 2, this is angle 6. 2 and 6. What are they? They are corresponding angles, and corresponding angles are equal, but angle 2 and angle 6 are corresponding angles, and they are equal. So therefore lines are parallel. L is parallel to M. Why? Axiom 2. If corresponding angles are equal, lines are parallel. So with this we have completed your theorems, and I am going to recap it. See here. See. What is that? Axiom 1. If lines are parallel, corresponding angles are equal. Clear? Axiom 2. If corresponding angles are equal, then lines are parallel. You see this pair. If lines are parallel, corresponding angles are equal. If corresponding angles are equal, lines are parallel. Now comes theorem 1. If L is parallel to M, then alternate interior angles are equal. Theorem 2. Converse. If alternate interior angles are equal, then lines are parallel. Okay, so this is couplet. Now theorem 3. If L is parallel to M, then interior angles on same side of transversal are supplementary. Supplementary means the total is 180. Theorem 4. If interior angles on same side of transversal are supplementary, then lines are parallel. See, hold the moral of a story you got here. If lines are parallel, corresponding angles are equal. If corresponding angles are equal, lines are parallel. Axiom 1 and axiom 2. Theorem 1 and 2. If lines are parallel, alternate angles are equal. If alternate angles are equal, lines are parallel. If lines are parallel, interior angle on same side of transversal are supplementary. If interior angles on same side of transversal are supplementary, lines are parallel. Clear? Now see, we are going to prove last theorem. Lines which are parallel to the same line are parallel to each other. See, it is like a tongue twister, but try to understand. Lines which are parallel to the same line. See, I can say A is parallel to C and B is also parallel to C. So these two lines, A and B, they are parallel to same line, that is C. A parallel to C, B parallel to C. So these two are lines. So lines which are parallel to the same line. Same line means here C. C is the same line. Same line. So these two lines are parallel to C, that is same lines, then they are parallel to each other. So you are given that A is parallel to C and B is also parallel to C. So these two lines are parallel to the same line. We have to prove they are parallel to each other, that is we have to prove A is parallel to B. So here we will see the proof. See, here it is given, first one, A is parallel to C. A and C are parallel. Okay, so A is parallel to C and transversal T intersect A and C at P and R respectively. So A is parallel to C and transversal T intersect A and C at P and R. So we can say angle 1 is equals to angle 3. So therefore angle 1 is equals to angle 3. Why? Corresponding angles. Corresponding angles. Have you got it? What? If lines are parallel, corresponding angles are equal. So here A is parallel to C. Lines are parallel. So corresponding angle 1 and 3 are equal. Clear? Now, second. B is parallel to C. B is parallel to C and transversal T intersect B and C at Q and R respectively. Clear? See, I have taken data. B is parallel to C and transversal T intersect B and C at Q and R respectively. So these two lines are parallel and this is a transversal. So I can say 2 is equals to 3. So therefore angle 2 is equals to angle 3. Reason, corresponding angles. Now 1 is equals to 3 and 2 is equals to 3. So from 1 and 2, what you can say now? 1 equal to 3, 2 equal to 3. So I can say now 3, 3. So I can say 1 is equals to 2. So therefore angle 1 is equals to angle 2. So 1 is equals to 2, but 1 and 2, they are corresponding angles and they are equal. So these two lines are parallel. So I can write, but angle 1 and angle 2 are corresponding angles. And they are equal. They are corresponding angles and they are equal. So therefore we can say A is parallel to B, hence proved. So altogether we have learned 2 axioms and theorems. 5 theorems we have learned today. Okay. So 2 axioms we have learned, axiom 1, axiom 2, theorem 1, theorem 2. These are the 2 theorems related to alternate angles. These are the 2 axioms related to corresponding angle. And these are the 2 theorems related to interior angles on same side of transversal. And this is the last theorem, theorem 5. Okay, lines which are parallel to same lines are parallel to each other. I hope you understood this theorem. In the next lecture, we will proceed with the problem of exercise 6.2. Thank you.